Okay, supaya yang baru datang, tolong record your attendance on Putra Blast. Okay, so next one. We talked about transmission from one medium to another, which is also refraction lah for light. Light is called refracted when it travels from one medium to another. For other waves, you just call it transmission. So when it is transmitted or when it propagates into another medium, so this is medium 1 and this is medium 2. What is retained? What is retained? What is the property that the light retains? So the frequency stays the same, okay, but V and lambda changes. So okay, so it goes into medium 2, frequency stays the same, but V and lambda changes. This is, if you can't remember what changes, what is constant, remember this equation, V equals to F lambda or lambda F. F is constant, which means that V and lambda should change. Okay, so these are the three things that you need to consider, right? When you are propagating, when light is propagating into another medium. All right, so we talked about reflection, refraction, Snell's law, TIR. Okay, back to mirrors. Okay, so for mirrors, we talked about how to draw the ray diagram, right? Ray diagram. We just talked about the ray diagram first. So we had pole. Pole is the center of the mirror. Okay, and then we had the principal axis, which goes through the pole. Okay, so it's a straight line that goes through the center of the mirror. And then we had, apa lagi ya? Is it object? I forgot. Okay, let's look at the slide. Teruknya. Okay, let's look at the slide. There's a bunch of points that they said that we have to draw. Oh yes, focal point and C. Thank you, forgot. So let's do that. Focal point. Focal point, which is called F, and your radius or center of curvature. So it's called C, or you can label it as R. It's the same thing, R or C. So if I were to draw a converging lens, so converging lens is a converging mirror. Converging mirror is concave, so it looks like caving. Is it right? Okay, I hope I'm right. And then this is your pole, the center, that's your pole, and your principal axis will go through your center of mirror. Okay, and then label your focal point depending on what the value is. And remember, your center of curvature or radius of curvature is always twice of focal point, focal length. So this is R. Let me label this as R. Okay, so your mirror cannot let light pass through, it's opaque, right? So if your light comes from here, sebenarnya dia tak pergi ke belakang, dia tak akan pergi ke belakang. It travels in a straight line, and when it hits a boundary, which is your mirror, it converges or diverges. But in this case, it will converge because it's a concave. That is your first ray. And then your second ray, let's say our object is here lah. Okay, this is our object. And then your second ray will go through the center of curvature and back onto itself. So that is your second. Okay, so that is your second ray. So the intersection between ray 1 and ray 2 will give you your image. Okay, so that is for a converging lens. This is your image. This is your object. So again, I told you yesterday, if you start your ray from the top of the object, you will intersect at the top of your image. So the intersection is the top of your image lah. If you want to find out where your center of your object is, that is what you get, the center of the image. Okay, so it depends on where you start. So I encourage you to go for the top lah, sebab senang. And memang confirm lah that that will be the height, and that will be your, senang lah pakai top, tak payah pakai center pun tak apa. Okay, that is how they do it anyways. Alright, so that is your recap, banyak pula. Let's continue. Kita tengok yang ni. Okay, so this is converging. Oh, there's another thing that I forgot. If it's real, it means that it is in the same place as you are. So if your focal point is at the same place, I mean in front of the mirror, because you are also in front of the mirror, so your focal point is positive. But if the focal point is behind the mirror or is somewhere that you can't go, of course you can't go behind the mirror, so that is called a virtual distance. So a real focal point is positive and a negative focal point is, a virtual focal point is negative. Okay. Moving on, stop sharing. I'm gonna share my slide now. Okay. Okay, kat sini kan kita stop. Ke kat mana? Okay. We stopped at convex. Okay, so continuing with convex mirror. Draw the principal axis. Yes, we know this. Place the mirror. Okay. Mark the focal point and the center of curvature. So the focal point of a convex mirror, which is a diverging mirror, is at the back of the mirror. Okay, so it's at a virtual place. So this is a convex. Convex or diverging. So diverging mirrors, diverging lens, dua-dua akan ada negative focal point. So anything diverging, negative focal point. It's always the case. So negative focal point because it's at the back of the mirror. For lens nanti kita akan belajar. So here, this is my object. I draw a straight line, hits the boundary. What happens? It diverges. So I need to diverge my light lah. So diverging my light, but it should go through the focal point, and then I extrapolate this light to find out where it is reflected. So again, draw a straight line, hits the boundary. I want to diverge this light, but I don't know how to diverge it. So I need to go through my focal point first to extrapolate where my reflected light goes. Okay, and this is the first ray. Second ray is through the center of curvature back onto itself. So where does it intersect? Saya tak nampak. Kat situ tak nampak dah. So into center of curvature, back onto itself. So this is where you intersect. So that is where your image is. We started from the top of the object. We will get the top of the image. So that is your image. So this guy is called U. And this guy, this is called the distance of object to mirror. We'll see this used in an equation. I'm just introducing it to you first. And this guy, the distance from the mirror to the image is called V. In your textbook, if you will read your textbook, it's called P and Q. Sama je. It's just a notation. So in this slide, we will use U and V. Okay. Next one. Okay, so ray diagram for concave mirror. So the ray diagram, if your object distance is greater than the radius of curvature, the image is real, inverted, and smaller. Okay, so the way that you don't have to memorize for this is if you can draw the ray diagram. So draw the ray diagram correctly, you don't have to memorize it. Okay, but if you want to memorize it because you like it, so you can do that as well. Okay, so here, the first ray, straight line, hits the boundary. Where should I go? I want to converge because this is a concave mirror. So I will converge into my focal point. Okay, that's my first ray. Second ray goes into the center of curvature, back onto itself. And this is my intersection. So that is where my image forms. So it is inverted and smaller. And it is real because it is in front of the mirror. So real means in front of the mirror. Okay, so this one is another example. I have an object that is smaller than the focal point. So this is my focal point and this is my object. This is my U. This is F. So U is less than F. What happens? So draw a straight line, goes into the focal point. Okay, I need to extrapolate it. if I need to, but mula-mula saya tak tahu lah saya kena extrapolate kan. Okay, so let's just start with not extrapolating first. So go straight line, hit the boundary, goes into the focal point, and then I need to withdraw into the center of curvature. So now I can't see an intersection. So what do? I extrapolate. Maksudnya saya extend line yang saya dah ada. That is what extrapolate means. So I am extending the line that I already have, and the intersection, I find it here. So that is where my image is. So here my image is virtual because it is at the back of the mirror. Virtual at the back of the mirror. It is somewhere that I can't reach because it's at the back, right? And then it is upright and larger than the object. So if you can draw the ray diagram correctly, you will find this out as well. Okay, so any distance for a convex mirror. Tadi we were talking about concave mirror. So concave mirror, mula-mula it was greater than the radius of curvature. So you got a smaller and inverted. And then when it is smaller than the focal point, you got something that is bigger and upright. Now we are talking about convex mirror. Convex mirror, at any distance, the image will always be virtual, upright, and smaller. This is true for any distance. Okay? And again, remember your convex mirror is a diverging mirror, which means that your focal point is at the back of the mirror and also your center of curvature. All images formed by convex mirror are virtual, upright, and smaller. So the one that you see at the store, macam 7-Eleven kan, saya rasa lah, dia ada mirror yang kat ceiling tu, bukan kat ceiling, dekat penjuru ceiling tu. So that is a convex mirror. What you see reflected onto that mirror is, if you are here, you see that you are here but smaller. So that's the convex mirror. You are always upright, smaller, and virtual. Okay, virtual tu saya tak tahu nak cerita macam mana, but you are always upright and smaller in that mirror, right? So that's the mirror that they use in the kedai lah. Okay. Okay, so this is just an example. Sekejap, kenapa dia tak tunjuk? Oh, ada kat sini. Okay. So convex mirror, any distance, virtual, upright, diminished. For concave mirror, you have to do extra work, draw the ray diagram to find out if it's real or virtual, if it's inverted or upright, or if it's diminished or magnified. If your U is at the focal point, there is no image form. I haven't tried that one. Kalau kat focal point jadi apa? Oh, memang tak boleh lah nak form. Okay, so this is something to highlight. No image form if your image is exactly at the focal point. Okay. So this is the equation that you will use to accurately find. If they don't give you, if they don't want you to draw the ray diagrams, you should use the equation. So again, this is the distance of the object to the mirror. To mirror, alamak, teruknya. Saya buat abbreviation je lah. O to mirror. OBJ to mirror, M. This guy is image to mirror. And then F is just focal point. You know this already. Okay, again, focal point for converging lens, positive. Focal point for diverging lens lagi. Focal point for converging mirror is positive. Focal point for diverging mirror is negative. Diverge, converge, F is positive, diverge, F is negative. Converge apa? Cave. Diverge, vex. Concave, convex. Okay? Sorry for the bad handwriting, but you get it. Okay. Now, sign convention. We already talked about this. Positive if it is in front of the mirror. Negative if it is at the back of the mirror. Okay, so magnification. You've seen this equation, I believe. So magnification is the height of object. Rasanya kenapa dia prime? Height of the object ke height of the image? Oh, it's height of the image. Height of the image over the height of the object. Kejap Saya baca dalam buku teks lain tadi. Height of the oh betul, height of the image. Okay, height of the image over the height of the object. Okay, and this is negative distance of the image to the mirror over the distance of the object to the mirror. This equation can be used for both converging and diverging. Okay, let's do this example. Excuse me. Okay.
Doctor.
Yep.
Why is the magnification is negative for inverted image?
Oh, forgot to mention about that. Yes. Kalau magnification is greater than 1, m is greater than 1, then it is magnified. If m is less than 1, it is diminished, maksudnya dia smaller. If m is equal to 1, no magnification. I mean, it's exactly the size of the object. I don't know when this happens, but if, let's say, the answer is 1, so there's no magnification because it's just the same height, okay, when it's equal to 1. So greater than 1, magnified, less than 1, diminished, and if m is positive, it is upright, and when m is negative, it is inverted. I don't know why. I don't know why. Memang macam tu equation dia. Saya tak ada explanation tertentu untuk cerita yang ni kenapa saya tak tahu. Memang positif, upright, negative, inverted. Thank you for reminding me. Saya terlupa nak cerita pasal ni.
Okay, thank you.
Okay, so m, again, m that is greater than 1, magnified. Less than 1, smaller. M equals to 1, no magnification. Positive, upright, negative, inverted. Okay. Okay, now we can start doing our exercises. Okay, so a virtual image is formed. Line. Saya nak share. Stop sharing. Share screen. Where's my? Katalah kepala saya tu kenapa. Okay, where is it? Where is it? Okay, it's here. Ruler, grid line. Okay. A virtual image is formed 20 cm from a concave. Concave, hello, kenapa tak boleh tulis? Concave. Oh, tak boleh tulis. Sekejap. Kecil lah, bila jadi macam ni. Okay. So a virtual image is formed 20 cm from a concave mirror. So concave, converging, just writing down like basic info about it. Having a radius of curvature of 40. So your C or R is 40 centimeter, which means that your F is 20 centimeter, right? Because 2F is R or C. Find the position of the object. So can we solve this using the equation or can we just draw the ray diagram? Don't know, let's do it. I haven't done it myself. 1 over U, 1 over V, 1 equals to 1 over F or 1 over F. It's a concave, so it's converging, so our F should be positive. So 1 over 20 centimeter. Virtual image. So virtual negative 20 centimeter. So this guy becomes 1 over minus 20, 1 over U. So find out what is U. So that is 1 over 20 plus 1 over 20. If everything is in centimeter, your answer should also be in centimeter. So that is 2 over 20, which means that, I don't know, 1 divided by, so it's 10 centimeter. The answer is positive centimeter. So U is positive 10. Positive means that it is real. So yeah, it is in front of the mirror. Real means in front. Okay, saya ingatkan nak kena lukis ray diagram. That's why I put the grid lines. Okay, kita off balik. Semak. Okay, next one. A convex spherical mirror. Spherical, convex, F is, it's happening again. Sekejap ni. Drop. Why is this happening? Yay, okay. Convex, so F is negative. Focal length is 15 centimeter. To form an image 10 centimeter from the mirror. From the mirror, where should the object be placed? So convex, the image is always, sekejap, kita tulis 10 centimeter dulu. So for a convex, the image is always upright, diminished, and was it virtual? I forgot. Virtual ke? Balik buku. Is it virtual kan? Okay, so maksudnya if it's virtual, your V should always be negative. So using the equation 1 over U, 1 over V equals to 1 over F. 1 over U, tak tahu. 1 over minus 10 equals to 1 over minus 15. Yes, I know this looks like a boring equation, but ada juga yang tak tahu nak buat. So let me just go through it together. So 1 over 10. So please bear with me, siapa yang dah pandai tu. So your U is 30, it's positive 30 centimeter because this guy was in centimeter, this is also in centimeter. So your answer will also be in centimeter. If you decide to convert everything in meter, your answer will be in meter. Okay, so U positive 30. Positive means real. So in front of the mirror. Okay, so we are just getting to know these terms. If it's positive, what does it mean? If it's negative, what does it mean? Okay, next one. 2 centimeter high object is placed 10 centimeter in front of a mirror. So this is high, so it's the height. So this is your object, HO, 2 centimeter in front of a mirror. What type of mirror and what is the radius of curvature? So type of mirror, this is relates to your F, if it's positive or negative. What radius of curvature is needed to create an upright image that is 4 centimeter high? Kenapa dia macam ni? Oh, okay. So it's asking what is the radius of curvature. So it's asking what is R. Tak boleh pula. Sorry, terlepas perasaan pula. Okay, dapat dah. So R apa? To get an upright image that is 4 centimeter high. So basically you have to know what your F is lah. Because F relates to R. And then you have to solve for F first lah. Okay, so it's asking you what can we do? What is the focal point? What is the focal length to create an upright image that is 4 centimeter high? So how should we do this? Upright image. So we have the height of the image, right? 4 centimeter high. So if we have the height, what is the equation that we can use? Anyone? If we have the height, what is the equation that we should use?
Magnification.
Yeah, magnification, which is HI over HO equals to minus V over U. So I have HI as 4 centimeter, this guy as 2 centimeter, and what's radius of curvature? Okay. Upright image that is 4 centimeter. Don't know how to solve this sebenarnya. I have not figured it out. 4 divided by 2 is 2. So your magnification is 2. Apa ni? Kenapa jadi macam ni? I don't want you. Keyboard, go away. Yes. Okay, sambung balik. So 2 equals to, now we have this equation. 2 equals to minus V over U. So upright image magnification is positive kan? Positive 2, betul lah. Okay, so we have another equation to go for. 1 over U plus 1 over V equals to 1 over F. I have this equation. I can substitute it, but how do I solve it? I actually don't know. Can anyone help me? Converging positive 40. Oh, ada ni lah. Ada U. Forgot. Yay, ada U. So U is 10 centimeter. Okay, so I have my U. So U is 10. So minus V over 10 will give me a V of minus 20. Okay. 1 over U. U is 10. 1 over minus 20 will give me my focal point. So focal point is 1 over 10 minus 1 over 20. So its focal point is positive 20 centimeter, which means that my R is 2F or 40 centimeter. Hello. Yee, kenapa tiba ni? Oh, tiba. So that is that. Okay. Any questions so far? Betul tak? Yep. Okay. Converging. So focal point positive. Positive 20 centimeters. So it's a concave or converging lens. Mirror. Concave mirror. Converging. Okay.
Doktor,
Hmm.
do we need to determine the concave or convex at the end of the answer?
If you can answer converging pun dah okay dah.
Okay, thank you, Doktor.
Okay, any other questions? Is everyone okay? So we know what is positive, what is negative, what is the magnification. If it's positive, it's upright. If it's negative, it's inverted. Converging, positive focal point. Diverging, negative focal point. Stuff like that. Those are the terms yang you have to be familiar with. Okay, is the next question? Okay, the next question is about lens. So let's continue with our slide. Stop sharing. Am I recording? Yes, I was recording today. Okay. Share. Sharing. Okay. Okay, so we are going into thin lenses. What time is it? Let's take a break. 10 minutes. Come back. If you haven't signed in your attendance, please do so. Let's come back at 11:55, okay? Any questions are also welcomed. Sign in attendance and questions, and take your break, 10 minutes. Excuse me. Optics. Excuse me. Apa? Sekejap.
Mine. That's mak.
No, it's not yours.
What's this boy?
Tak boleh. Oh, ini kan violin, tak boleh. Wait.
It's boy.
No, it's a boy. Jadi sing lah. Duduk dekat luar. Go outside. Bye. Let's make an equation. Where is it? Okay, this is too much. Come on, introduce. displacements does dah terlebih masa. Is everyone back?
Yes.
Pada
Yeah.
35 je. Oh, Adam Daniel, Akmal Daniel and Faris Hazrin. Are you here? Okay, sebab dalam attendance pun tak ada. Right, so I'm going to assume that you're not here.
Doctor, I want to ask something.
Okay.
What is the field of view is maximum for convex mirror?
Max.
Is it convex mirror, the image of convex mirror will diminish or what?
Lagi sekali, awak cakap the view for convex mirror is maximum.
Yes, because ada sekali dia tanya the field of view is maximum for tak apa. So the answer is convex mirror. Why convex mirror?
Ni soalan web design
No.
Oh, cakap maximum
My own
revision. Maximum field view. Tak tahulah. I need to get back to you on that. Kejap. Nak tulis dalam buku. Maximum field view. Tak belajar pula pasal tu. Okay, let's continue. Nanti saya get back to you. Tadi siapa yang tanya saya soalan tu?
Syakirin.
Syakirin. Alright, Syakirin. Nanti saya get back to you. Okay, let's continue with lens. Okay. Okay, so lens, just now we talked about mirrors and how is mirrors different than lens? Lens ni sebenarnya benda yang transparent like this kanta over here, like our glasses. Our glasses yang kita pakai tu, yang spek mata kita tu is called lens. So maksudnya kita boleh nampak, it's see-through lah, it's not opaque. Kalau mirror yang kita tengok kat bedroom semua tu, tengok nak berhias, nak bersolek semua, that is dia opaque kan, kita tak nampak belakang dia apa. But in this case, for lens, we can see what is at the back of the lens. So it's almost transparent. Okay, so we have biconvex, convex, concave. So kat sini, sorry, saya tengah gagap pula. Previously, we talked about mirrors and converging is concave, right? And convex was diverging. For lens, it's the opposite. So for converging lens, it's called a convex lens. And for diverging, it's called concave. Diverging lens, Diverging lens is called concave lens. So dia terbalik. Okay, but converging, the way that we drew it for a mirror was like this. But when we, saya lukis dulu. When we hit the light, when we hit the mirror, when light hits the mirror, because of its shape, it converges, right? Converges like that. Whereas for a diverging mirror, when the light hits, because of its shape, the light goes like that. So tak? Sebab shape dia macam tu, so it diverges or converges. So kalau dia cave in, it will converge. For lenses, kalau converging, it looks like this. Kita balik. And then the light that hits it, and because it is, the light can go through, right? Tadi when the light passes, it will reflect. Right now, when the light passes, it refracts. Okay, kat sini, reflects. For this guy over here, it refracts. Okay, now we see that the shape is like a cave. Tapi dia kat belah sana. So it converges. Sama tak macam ni? Sama kan? It's almost the same. So when light hits, because it's not going to be reflected, it's going to be refracted. So it depends on the surface over here. So this surface looks like a cave, so it will converge. Okay, and again, so diverged lens looks like this. Tak tahu lah nampak ke tak ni. So I'm just gonna try. Let's use a color that will be very transparent, but very clear. So light goes through, hits a boundary. The boundary is your lens. It can pass through. It's not going to be reflected, so it's going to pass through. So it follows the shape of that boundary. Sama tak? Macam sama kan? So this is, bayangkan light lens macam ni, dia pass through, macam tu, sama. So if they draw and you can't remember what it is, kalau mirror hits the light reflected, look at the shape. Lens, light hits the boundary, it goes through, it refracts. Look at the shape that it hits, right? Where should it go? So converging looks like this. It's a convex lens. You don't have to memorize the name, but you need to know which one is converging, which one is diverging. This guy hits the boundary. Look at this shape, it is going to diverge. So it's a diverging lens. Okay, so that's just a tip that I use to remember for myself. If that does not work for you, please find your own method to memorize this. Doesn't matter how you do this. You don't have to follow me. Everyone learns differently. Okay, so a thin lens consists of a piece of glass or plastic or whatever that is transparent. With each of its two refracting surfaces is a segment of a sphere or a plane. Don't have to memorize that. A thin lens refracts at the lens surface. Tak payah baca ni. Let's go on. Okay, so these are the examples of converging lenses. They are the thickest in the middle. So yang ni, dia cakap kat tengah-tengah ni paling tebal. Whereas for diverging, it is the thickest at the edges. Okay, so tu je. It's just giving you a characteristic of the converging lens and the diverging lens. Will they ask about this? I'm not sure. Maybe they can ask if a characteristic of a converging lens. It's thick in the middle. It converges light. It's called a convex lens. They could ask that. Okay, so fair game as long as it's in the book. Okay, so parallel rays from a distant object passes through a convex lens and converges. Okay, so for mirrors, we had ray 1, which was going in a straight line until it hits the mirror, and then it will either converge or diverge depending on where the focal point is. For a concave, your focal point was over here. It was in front, it's real. So you had this, this is F. You had to go through this one, and then there was another ray that you had to go through C and back onto itself. So ray 1, ray 2, like that. Whereas for lens, oops, sorry. Okay. Hello. So this is my object. Sorry, I forgot to label the object. For lens, you have parallel rays hit a boundary, refracted, and it goes into the focal point. Hits the boundary, goes into the focal point. Hits the boundary, goes into the focal point. Sekejap. Lens. Parallel rays goes into the focal point, and the other ray is going through the center. This is not the slide. Sekejap. Okay, so here this slide is just showing you that convex lens, they have parallel rays that goes into the focal point, it converges, and then this guy goes into the ray, it is refracted, which means that it is going to diverge. Okay, silap macam ni, diverge, but at the center it goes straight. Sama juga kan, at the center it goes straight, the center it goes straight. So that's the property of a lens, at the center it goes straight. Everywhere else it diverges or converges. Okay, so let's look at this example. A focal point of a converging lens. So it's a convex lens. So straight line hits a boundary, gets refracted. Straight line hits a boundary, gets refracted. Straight line goes through the center, straight. Sepatutnya straight lah. Tapi yang ni tak berapa center. Straight line hits a boundary, converges. And this one is concave. Straight line hits a boundary, diverges. Okay, and so on. Here, your object will be, the focal point of the converging lens is the opposite side as the object. So it's saying that the focal point is here. The focal point is real and the focal length is positive. So anything that is at the back of the lens is real. Anything that is in front of the lens is virtual. It's terbalik dengan mirror. Mirror in front of us, in front of the mirror was real. At the back of the mirror was virtual. For lens, because light is supposed to go through, so light is real at the back of the lens and light is virtual if it's in front of the lens. So terbalik. The focal point of a converging lens is on the same side as the object. So if your object is here, the focal point for a diverging lens will be at the same place. So it's a virtual focal point. The focal point is virtual and the focal point is negative. Anything that is virtual is always negative. This goes for both lens and also mirror. So virtual, always negative. Okay, virtual is always negative. So mirror, virtual at the back. Virtual is at the back. Virtual is at the back of the mirror. Whereas for lens, virtual is in front. Lens, virtual is in front of lens. Okay, so there's another thing that you need to know about lens. Lens has two focal points. Sekejap, is this the equation? Kat mana dia nak cerita pasal focal point ada dua ni? Jauh pula. Oh, kat sini. Jauhnya. Okay, never mind. Kita akan sambung nanti. I mean, not sambung nanti. I mean, I'm going to tell you about focal point tu kejap lagi. Kenapa ada auto recovery pula ni? Sekejap Okay, so virtual for mirrors is at the back of the mirror. That is where light is not supposed to be. For lens, because your light is supposed to go to the back of the lens because it's transparent, that is where your real is, which means that in front of the lens is where your virtual is. Yeah? So it's diikut fitrah lah kononnya. Okay? Virtual tu tempat yang sepatutnya dia tak berada. Okay, so a focal length of a lens is related to the curvature of its front and back. What is the curvature of its front and back? So we've seen tadi dalam gambar awal-awal tadi, but never mind. In your textbook pun ada biconvex, ada convex concave, ada plano convex, biconcave, convex concave, and so on page 141. So you have a bunch of different lens. So it looks like this. Macam biasa lukisan saya is bad. Okay, so there's a bunch of lenses, different types of lenses. And these things are called curvature. Okay, these things are called the curvature. And for a flat curvature, Okay, it's like your flat mirror. The one that you use in your bathroom, in your bedroom is a flat mirror, right? So it has a flat curvature whereby the R is infinity. So the distance is infinity, okay? And for this guy, the curve, if it's curving outwards, the R is positive. If it's curving inwards, the R is negative. So this guy is curving outwards, positive. Curves outwards, okay, dia terkeluar, so R positive. Curves outward, R positive. So that is how you determine whether your curvature is positive or negative. If it's going outwards, it's positive. If it's going inward, it is negative. And for a flat mirror, the R is infinity, which means that 1 over R, 1 over infinity just means 0. Okay, so here, let's look at this equation. It's 1 over F. F is your focal point. We know this. N is your index of refraction. Index of refraction. Okay, and 1 over R1 plus 1 over R2. This is your curvature. Okay, which one is R1? Which one is R2? Good question. Cik, walaupun korang tak tanya, saya cakap good question to myself. Curvature of mirror. Okay, which one is R1? Which one is R2? So again, lens, the light can pass through, right? So it doesn't matter where light is. I mean, light can go from here, light can go from here. It doesn't matter if it's in front or if it's from the back. But the way for you to determine which one is R1, which one is R2, or which one is in front, which one is at the back, is where you are shining light. Where is your incident light? For example, I am using a torchlight, right? This is, my God, this is a bad torchlight. So my light is this way. This is where my incident light travels. This is called in front, and this is called the back of the lens. So this guy, if it's in front, this guy will be R1, and this guy will be R2. It depends on where your incident light is. Okay, that is how you use the equation. So this is called the lens maker equation. R1 and R2 are positive for convex lenses, converging, and negative for concave lenses, diverging. You don't have to memorize this. Just look at the shape. If it's going outward, it's a positive. If it's going inward, it's a negative. Question? Okay, everyone okay so far? Okay, I'm going to continue. Okay. Okay, so let's look at this diagram. I took it from your textbook just now. So here, this is the front because this is where your incident light is. This becomes your front or your virtual side because light passes through, right? So when it can pass through, this guy becomes the real, this guy becomes the virtual side. Okay. P is positive, P is your U. If U is formed here, I mean, if object is here, it's positive, and this is your image. If image is formed at the virtual side, it's a negative. And then if your U is here, your object is here, it's a negative. It's negative. If your image is here, it's a positive because that is where your image is supposed to be forming. Okay, again, this is where your incident light is. Okay, object can be here. Image also can be here. Let's make a table. Oh, there's already a table, forgot. Rasa macam tak clear macam ni. Sekejap Okay, so this is the front because you have your incident light here, you have your refracted light over here. Light that passes through, so naturally we will assume that the image is supposed to form here. So if my image is supposed to form here, this becomes the real side, and the place that it's not supposed to form an image becomes the virtual. However, it doesn't mean that the image cannot be formed there. Boleh je. Object can be in front or behind the lens because the key thing here is incident light. So here object can be in front, object can be at the back. Light is from one side, object can be in the front, object can be at the back. Image can also be in the front, image can also be at the back. Okay, if object is in the real, if object is in the front, as the same place as incident, it is a positive. So object and incident light together, they are positive at the same place. If object is not with this at the same direction as incident, it is a negative. The image, I keep confusing image with I and V. Okay, so V is image. V and incident, if they are at the same place, it's a negative. If V and incident, V is not the same place as incident, which is naturally how we assume things, it's a positive. Okay, so incident light ni penting untuk lens. Okay, same place, good. Not in the same place, negative. If image and incident not in the same place, that is how we naturally assume it to be. It's a positive, and if it's together in the same place, it's negative. Okay, so object location, this is the table. You can find it in your textbook if you want. Okay, sama juga, it's just summarizing what I said. So image location, if it's in the front of the lens, it's a positive. If it's at the back, it's a negative. Image location Q, if it's in front of the lens, this is not where we assume it to be. It's negative because it's at the virtual side. Positive if it's behind the lens because that is where we want it to be. Lens radius is R1, R2, radius of curvature. Wait, sorry, we call this curvature for lens. For the front part is negative. Kejap, ini apa? Okay, I'm not sure what this is. Kejap. Focal length is convergent positive. We know this from mirrors as well. Everything that is converging is positive. Everything that is diverging is negative. Kejap, lens radius ni apa? R1 in front is negative, in the back is positive. Okay, let me get back to you on that. Not sure kenapa dia cakap in front ataupun back, as I know that it should be dependent on the shape. Is that what it means? The front? I don't know. Tak faham. Nanti saya baca balik. Okay, let's do this example. What time is it? 12:20. Okay. 11.13. Stop sharing. Any questions? Please feel free to ask. Adam Daniel, awak tak sign in attendance lagi tadi. Tolong sign in Saya check tadi tak ada nama awak. Oh, saya rasa dah tak boleh sign in dah. Jadi saya check balik.
Okay, Doktor.
Saya rasa saya dah tutup dah. Is Akmal Daniel here? Akmal, are you there? Okay, Akmal tak ada. Sekejap let's do this one. Oh, what happened? Hello. Okay. Sekejap paling menyampah benda ni. Okay. Paste here please. Okay, good. What happened? Gendut tau benda ni. Nampak. Okay. Maybe 14. Okay, it's here. Alright, dapat dah semua. Okay, let's do this. So example 11.13. Not sure if it's here on in the book. Is it? Ada. Okay, it's in your book 142. A converging lens. So converging focal point, focal length always positive. Positive F. With two curved surfaces has a front surface with radius of curvature 10 centimeter. So the front is 10 and the back surface is 20. Okay, so it's a positive, so that's why saya buat lengkung. And it is made from a material, yes?
Tak nampak screen.
Oh, sorry. Sekejap. Oh, saya babel seorang je tadi. Kejap, kenapa dia check? Saya pun tak sempat submit attendance. Okay, Faris. Share screen. Okay. Nampak kan? Okay kan? Okay.
Nampak.
Okay, so let's do example 11.13. It's in your book 142. So a converging lens with two curved surfaces has a front surface radius curvature 10 and a back surface of radius curvature of 20. So since it's giving me a positive value, I will assume that it is melengkung lah, okay, because that is melengkung akan jadi positive, right? And it is made from a material of index of refraction of 2.5. Keluar pun. So n is 2.5. And it is made, okay, what is the focal length of the lens? So kita ada equation lens maker. It's n minus 1. Is it n minus 1? Yep. N minus 1, 1 over R1, 1 over R2. So how should we use this? We know that our focal point is positive. We have our n 2.5 minus 1. 1 over 10 centimeter and 1 over 20 centimeter. Again, if you don't convert to meters, you will get your answer in centimeter. But make sure everything is in centimeter. Then you can solve for F. So F should be 4.44 centimeter. So that is how you do it. Pakai equation ni. Okay, pretty easy. Just have to know this equation. Next one, a plano convex lens with n of 1.5 is flat on one side. So it's flat on one side and we don't know if it's curved outwards or curved inwards or the other side. So this side is unknown. Okay. What must be the radius of curvature of the curved side to produce a converging lens of focal length 20? So we want a converging lens, so it's 20, so it's positive 20 centimeter. So our lens maker equation, 1 over F, n minus 1, 1 over R, 1 plus 1 over R2. And I told you before, for a flat surface, our R is infinity. So that means that we have 1.5 minus 1, 1 over infinity, which cancels out to 0. 1 plus 1 over, plus 1 over R2, that is unknown. And our focal length is 20, 20 centimeter. So use your calculator, you will find out that your R2 is 10 centimeter. Saya dah buat dah, so saya yakin jawapan dia 10 centimeter. Okay, so this is how you do it. Again, if it's a flat surface, 1 over infinity, or the R is infinity. Here they did not specify if it's R1 or R2, so it's either one, can be either one. Okay. 14, that was 15, 14, okay. A contact lens is made out of plastic with an index refraction of 1.5. The lens has an outer radius, so it's outer radius, curvature of 2, okay, and an inner radius, so inner radius. Don't know how the lens looks like, assuming it's like that. So inner radius of 2.5. Here they said is a positive, but inner means negative. Okay, so the value is 2.5, but for an inner radius, of curvature is negative. What is the focal length? 1 over F, n minus 1, 1 over 2, okay, plus 1 over minus 2.5. So n is probably 1.5. So solving for this, I calculated it already. Ini 11.14 kita tak. Okay, so the answer is 20 centimeter. Okay, sama. Sekejap eh. Sorry about that. Lecturer lain anak dorang kacau tak? Ke tak ada? Saya seorang je. Dia je. Okay. So I am back. Any questions for me? Untuk example, these 3 examples? Okay tak? Everyone okay eh? So let's continue with our slide. Stop sharing. Okay, so now we are going to draw the ray diagrams for thin lenses. Kita dah tahu flat lens are the infinity. The incident light is where it's in front, and the one at the back is at the back. We have the virtual side and the real side, right? The real side is at the back. The virtual side is in the front, where the incident light comes from. Okay, so those are the things that you need to remember. So continuing, 3 rays are drawn. The first ray is drawn parallel to the principal axis. Okay, maksudnya just parallel lines. Where is my pen? Just parallel lines. So let's say we have a lens over here. So our parallel lines, light will travel like this in straight lines until it hits a boundary. Then it gets refracted, either converges or diverges. So for a converging lens, your focal point, this is your principal axis, this is your focal point, it will converge into your focal point. Okay, like that. So the second ray is drawn through the center of the lens and continues in a straight line. So we already have that, but it looks like this. Kalau nak nampak lagi, this is where it is. It is at the principal axis, basically. Oh wait, kejap. Principal axis ni goes through ke tak? Does it go through the lens or not? Tengok gambar balik. Oh yes, it does. Okay, betul lah. Okay, so your principal axis is through the center of the lens, which means that the second ray goes through the principal axis lah. If there is no object, if we are just assuming that we are just drawing rays of light. Okay, so the third ray is drawn from the other focal point and emerges from the lens parallel to the principal axis. Usually I just go for these 2 because you will already find out what is the answer. So image location, image position is located on the cross section of the lines. Extrapolate if necessary. Okay, extend the lines if you need to. Let's do one. Draw the principal axis, must go through the center of the lens. Place your lens, mark the focal point, place the object. First ray is drawn parallel. Okay, from the top, let's use a different color. Let's use green. So from the top of your object, goes through. It does not reflect, it refracts because it's a thin lens, and it goes through the focal point if it is a converging lens. And the other one goes through the center. Okay, tadi we were drawing rays of light that is going in a straight line. Now we are drawing the image for an object. So tadi straight line saja, semua straight line. That's why we could go through the center like this, through the principal axis. Now we are drawing for an object. Kita nak tahu what is the image. So it's different, a little bit different. First straight line goes into the F, and then the other one goes through the center in straight line. This is where it intersects. That is your image. It is inverted. I'm not sure if it's diminished, but it is definitely inverted. Okay, the image. Okay, next one. This one is for a diverging lens. See here, the shape tells you to diverge. So your focal point is at the virtual side. Diverge. So where is our focal point? It's in the same direction as it's in the same place as the incident light. First ray is drawn parallel. You want to diverge it, so go through the focal point, extrapolate your diverged line, your diverged light. The second ray is drawn through the center, sama juga, through the center. Where does it intersect? It intersects over here. Okay, so something that maybe some of you are going to be confused is that you will draw your image here, or I don't know, because it intersects here, right? So sometimes this line confuses you, padahal ni line yang kita lukis. Line yang kita lukis tak, it does not make the image. So this is wrong. So the image is always with respect to the principal axis to your intersect. Again, your image is with respect to your principal axis to where you intersect. Jangan letak dekat udara image tu, please. Tadi tu pun sama. Principal axis and where you intersect, that is your image. Do not draw your image mid-air, okay? Principal axis. There's a reason for the principal axis to be there, okay? So that you know where to draw your image. All right. Ray diagram for converging lens. Here, dia nak tunjuk contoh je. So this is your object. So draw your first line straight, hits a boundary, converges into your focal point. Next ray goes to the center with principal to your intersect is your image. So it's inverted. So this is inverted, sorry, the image becomes inverted when your object distance is greater than your focal length. Again, you don't have to memorize this if you can draw this correctly. Oh, sorry, image is real and inverted. Forgot to mention that it is real. At the back of the lens, it is real. This is the opposite case for mirror. At the back of the mirror, it is virtual. At the back of the lens, it is real. Okay, so when your object is less than the focal length, it is virtual because it is in the same place as your incident light. We don't want that. We usually want our light to be at the back of the lens. So if it forms in the same place as your incident light, it is virtual. Here it is magnified and also upright. Okay. So straight line, this is your object, straight line, converges into the focal point, and then another line goes into the center of your lens. I can't find an intersection, so what do? I extrapolate. I extend the line that I have. Again, referring to the principal axis and then referring to where it intersects, that is your image. Okay, always refer to your principal axis. Okay, this is for a diverging lens. The key thing to remember about diverging lens is that your focal point is negative, maksudnya it's virtual. Virtual maksud apa for lens? It is in the same place as your as your incident light. So this is your focal point. Your incident light is over here, or your object, sorry, your incident light. So goes through here, goes through the focal point, and then through the center, back onto itself. This is where it intersects. This is your principal axis. So that is where your image forms. Okay, your image is forming in front of your lens. It's a virtual image. It is upright. Okay, so lens equation sama macam mirror. 1 over u plus 1 over v equals to 1 over f. Focal point, focal length, object, and this is your image distance. Image distance to the lens and object distance to the lens. Which is positive, which is negative? If it's a virtual, negative. If it's real, it's positive. Kejap, we have that table. Is that related? Object location in front, P positive. Image location in front, negative. Okay. Image location, if it's at the back, it's negative. Image location, if it's at the back, it's positive. Okay, so that is your convention sign. for your equation tadi. Mana tadi ya? Okay, so for this case, your object is in the same place as your incident light because this is front, this is back. Okay, so the rays of light is like this. So this, it means that this is the front part, right? So front U that is over here, positive. V that is in front is negative. So your equation will be 1 positive U, 1 over negative V equals to 1 over F. Okay, if you already know what is your focal length, you can decide if it's positive or negative. But in this case, selalunya negative lah. Okay, combination of thin lenses, ada ke tak? I don't think so. I will get back to you on this. But for now, kita dah habis dah for our chapter 11. I think this part dah tak ada dah. Okay, let's do this question. Combination of lenses, I don't think there will be on the exam. If you know how to draw correctly for one thin lens, you will definitely know how to draw for two lines, but I'm pretty sure there's no combination. Let's do the example. Okay, so let me stop sharing this slide before we conclude our class with examples. Okay, jap, eh. If I'm too fast and you need to ask me question, please do so. Okay, please just ask. Kejap, sharing. Yep. Yes, okay, got it. Okay, so 11:15 dah buat, 11:16 belum. Okay. Apa hal? Okay, let's do this one. Okay, so an object is placed 30 centimeter from a lens. So let's just draw a random lens. Okay, saya tak tahu the lens jenis apa. So this is your object over here. O, 30 centimeter away from the lens. So if that is how it looks like. So this is your U. So it's U. And a virtual image, okay, virtual image, so negative V, is formed 50 centimeter from the lens. So if it is a virtual image, it means that it is forming in the front of the lens. Again, when light passes through, we expect it to go the other side because it is able to be refracted, right? If it is virtual, it means that it's at the side that we don't necessarily assume it to be. So it should be here. So it is, the image is here. I don't know if it's bigger or smaller, but I'm just going to draw it there. Okay, this one. Wow. Hello. Okay, this guy is 15. So that is V minus 15 centimeter. Okay, tak apa. Korang faham kan? So U is 30. Okay. And then this, they said that the image is virtual 15 centimeter from the lens. Virtual tu dah bagi tahu dah. So it is in front of the lens. Okay, and the value is going to be negative 15 if we use the equation. What is the focal length? So 1 over F. Do you use the lens maker equation? We don't have to because kita dah tahu kita punya 1 over U and 1 over V. 1 over 30, 1 plus 1 over minus 15. 1 over F. So I will get an F that is negative. I think I've done this one, 16. Yeah, the answer is negative 30, sama. Okay, so use your calculator correctly, should be no problem. B, is the lens converging or diverging? Just looking at this answer, I already know that it is diverging because positive always converges. So negative always diverges. This is applied both for mirrors and lens. Converging lens, converging mirrors, focal length is positive. Okay, it's diverging. Next one, senang je kan? Untuk mirror sebenarnya senang, cuma boleh lose mark kalau salah lukis, salah pakai equation. Tu je. So just make sure that you do it correctly. Okay, so and a thin lens has a focal length of 25 centimeter. So that is your focal length, 25. Locate the image when the object is placed 26. So dia cakap, oh image, oh dia cakap object. When the object is placed. So the first distance is 26 centimeter. The second distance is 24 centimeter in front of the lens. So in front maksudnya dia sama tempat dengan incident. This is what we want for our object. So it's going to be a positive U. Okay. Okay, so we want to know what is the V. 1 over F equals to 1 over U1, 1 over V1. U1 is 26. V1 we don't know. Focal length is 25. So solving using your calculator, V1 should be 650 centimeter. If my answer is positive, what does positive mean? It means that it is real. Okay, it means that it is real. Okay, soalan dia cakap describe image. So is this sufficient? Tak kot. Kalau ikut soalan ni dia cakap macam tak lah kan. Sebab dia suruh bagi tahu upright ke, magnified ke apa benda semua. So it means that we have to use the magnification equation. So M equals to minus V over U. So we know that our V is 650 centimeter and U is 26 centimeter. They have the same notation. They have the same unit, so I can cancel that out. So my answer is negative 25. So negative means inverted. This guy is more than 1, which means that it is magnified. So there are two information that you can get from the magnification. The sign will tell you if it's inverted or upright. And the value will tell you if it's magnified or not. Okay. B. Sama juga macam tadi. So F is 25 centimeter. Oh, dah tulis kat sini. You don't have to. Okay, let's do this in blue pula. 1 over 25 equals to 1 over 24. This is our U and we want to know what is our V2. So use your calculator betul-betul, jangan salah tekan. So V2 should be minus 600 centimeter. Now, looking at this answer, I already know, oh, okay, it's virtual. What does virtual mean? It means that it is in front of the lens. Okay, so positive at the back, negative, virtual in front. At the back. Okay, lens. All right, so now we want to describe how our image looks like. So let's use the magnification equation, negative V over U. Negative 600 over U. U is 24. So I will get an answer of 24, positive 24. Again, this guy is greater than 1. It is magnified. This guy is positive. It is upright. Okay, senang. Cuma kena tahu je positif maksud apa, negatif maksud apa. Ini banyak hafal sebenarnya. Okay, which is my least favorite. Okay, apa lagi soalan? Last one. I think there's the last one. Habis dah? Dalam buku rasa macam ada lagi satu. Sekejap Okay, kita nak habiskan je. Should we just finish class? Are you guys okay with that? Saya suruh buat sendiri last one tu.
Yes, okay.
Okay.
Okay, Doctor.
Alright, so let's finish class. The last question is about LCD. It's an application equation, which is typically what you will see in your exam. So please try to do that one. If you can't do it, let's discuss in class next Friday. Okay? Is that okay? And please start on your web assignment. Okay, so that's it for chapter 11. For Friday, kita akan discuss mana yang korang tanya about chapter 10. And if you have any questions about chapter 11, we will do that on Friday. Alright, so take care. Don't forget to eat. Stay safe. Jaga SOP. I will see you and all the best. Start studying for your finals. Don't give up. Okay? Bye-bye. Tu je.
Thank you, Doctor.
Thank you, Doctor.
Bye.
Doctor.
Thank you so
Bye.
much, Doctor.
You're welcome.
Bye, Doctor.
Bye.
Thank you, Doctor.
Welcome.